Hello, and welcome to the fourth unit of our first week in the course Avoid SAP S/4HANA project delays with third-party systems virtualization. My name is Marcin Gałczyński. In this video, I will discuss when to apply service virtualization in the S/4HANA project. Do you remember Sarah, the senior IT manager responsible for the project? She is very likely to work with a project plan resembling the one in this picture. The project will likely follow a waterfall approach. It will start with preparation, followed by a fit gap analysis with a detailed blueprint, build, testing, training, and go live with sufficient hypercare. While going through the details of these phases is outside of the scope of this course, I will zoom in on the blueprint, build, and testing. Service virtualization allows for delay reduction and acceleration in these phases. Sarah would by now understand the challenges of dependency on third-party systems and external partners. These become boldly apparent in testing and could pose a challenge as early as during the blueprint. Let's look closer at the blueprint. Specifically, in a brownfield approach, the existing ECC installation is converted to S/4HANA, keeping all the data and configuration. The project team can conduct a fit gap analysis on such a converted system. The team will also keep it as the sandbox system for the project. As an outcome, existing processes are up for validation and the team can decide on configuration updates based on an understanding of S4 behavior. Of course, conducting such validation on a sandbox system, usually disconnected from the rest of the landscape, would pose a challenge requiring either manual steps or using more technical tools like VA19 or SOAP test tools to simulate external data exchange. However, introducing service virtualization will enable smoother execution of transactions in the S/4HANA sandbox and thus accelerate the blueprint phase. Sarah will have to ask her team to balance the service virtualization efforts carefully against the rest of the project tasks. For example, there is no need to have a fully operational sandbox landscape virtualization during the blueprint. On the other hand, establishing service virtualization is an operation performed only once. Since it will bring benefits during the rest of the project, it makes sense to apply it early on. Although Sarah's team only started building the system, completing the build phase requires at least evidence of successful unit tests. Because of the lack of actual data in the development system, unit tests are usually done on simple documents and with minimal effort when testing integrations. Having an entire landscape available for the build team is not realistic. The costs of managing one would make it a luxury that the project team will likely not be able to afford. In other words, the coverage of the unit tests done in the build phase is limited. Sarah, of course, would like to have the build phase delivered with the maximum possible quality. A good build reduces the number of defects found later on during testing. Finally, it reduces the overall risk for the project. Introduction of service virtualization for the build phase allows for improvement of the unit test coverage without the burden of setting up external integrated systems or involving external parties. For example, the build team could test inbound order processing, e-invoicing, or external warehouse with service virtualization. Thanks to two factors, it will allow them to do more unit tests. The first one is test data availability. Virtualization will enable the easy generation of test data based on already existing messages. It will reduce the time needed to wait for the functional team to prepare test documents for unit testing eventually. The second is a byproduct of the first. Thanks to the speed-up gained by removed waiting time and easy access to test data, the development team can extend the coverage of unit tests while improving delivery quality. Sarah will again have to do a balancing exercise. Developments related to business-critical interfaces involved in daily operations should have excellent coverage in unit testing. As for them, any faults passing over to be discovered only during testing will introduce testing delays related to defect fixing of developments impacting several business processes. So, the business criticality of related work should drive the actual selection of virtualized systems. Once again, Sarah's team should consider that service virtualization introduced at the build stage will benefit subsequent phases, testing and hypercare. During the test execution, the benefits of the service virtualization application are apparent. As mentioned before, improved development speed and quality will help the build teams resolve defects. At this stage, it is common to see developments fixed in the development system and then transported to test systems only to see that more work on the development system is needed. With service virtualization providing test data for integrations already on sandbox and development systems, developers have higher chances to avoid this vicious cycle. Business teams usually complete testing. Their sign-off is required to close the test phase and move to cutover and go live. Typically, neither the business team nor external testing service provider can do the testing independently while testing integrated business processes. For example, with EDI orders, it's common to have some understanding of the underlying EDI document data and structure. However, Sarah could not count on the testers to produce EDI orders or validate EDI invoices. That would require extensive technical knowledge of the EDIFACT or X12 document structure format and rules guarding the content. Instead, the project team, the functional consultants supported by developers, will take over that work to generate and validate these technical artifacts. That again creates additional communication and dependencies and can create delays. As explained before, these delays would be longer if the testing involves external partners. Service virtualization will enable testers to work independently, cutting test execution time by eliminating delays. Once the testing is complete, service virtualization will remain helpful towards the end of the project, bringing benefits similar to the ones provided during build and the test phase. Following the go-live, virtualized partners and external applications will help accelerate more minor system changes and further developments. It is essential to mention that service virtualization does not replace testing. However, swapping external partners with a software solution mimicking their behavior is a powerful accelerator for the test execution. Sarah's team can now capture the benefits starting from behavior checks in the sandbox during blueprint, unit test acceleration, more extensive test coverage in the build phase, and finally, accelerating business testing before go-live. Where automated testing is available, it can also benefit from having service virtualization in place, as it enables test automation of scenarios that rely on interfaces. Sarah would see a similar pattern emerging if she went for the more agile approach and used a project plan based on agile methodology, for example, SAP Activate. Regardless of the applied method, the steps related to defining the design, development configuration, and testing still have to be executed. The benefits of service virtualization will apply similarly. Sarah implemented service virtualization at the early stages of the project. As a result, the team can validate more examples during the blueprint and design. In addition, developers have more test data and can use more scenarios for unit testing during the build. Finally, the testers can work faster, thanks to the independence gained from service virtualization. To name it more formally, the application of service virtualization increases testing coverage at the early stages of the implementation. This concept is known as shift left. It's an approach to software and system testing in which testing is performed earlier in the lifecycle, or in other words, shifted left in the project timeline. As we are approaching the end of this lesson, a quick summary. Service virtualization brings benefits starting from the design and exploration phases of the project. Service virtualization is an enabler for the shift-left approach, bringing testing early on in the project to avoid issues related to late testing. Service virtualization enables test automation for processes that require cross-system integration to run. I hope you enjoyed this lesson. See you in the next one, where Mateusz will show you what is the SAP project tailored service virtualization.